Greetings. Welcome to another week of data mining. At this point in the course, you almost have a complete methodology in place. You've built a decision tree which you've trained based on the data samples that you've been given. You're able to use your decision tree to classify samples. You've even assessed the accuracy, sensitivity, specificity, and other properties of your decision tree. Many of you have written some good analytical reports where you consider the effectiveness of the decision tree. Some of you have come up with some ways that you could perhaps improve the decision tree's performance. This is really great. There's one more thing that we're going to do before I would consider us to have a complete initial draft of a classification pipeline. So in addition to calculating metrics such as accuracy, we need to consider one other factor, and that is that we might have built a decision tree that only works for this particular data set. How do we know whether it's going to be effective on, let's say, 100 new samples that we might collect over the coming year? One way to test this is to do what's called cross-validation, k-fold cross-validation. And we're going to do an instance of cross-validation called threefold cross-validation in the coming week. So what we're going to do is we're going to take everything that you've developed, your decision tree construction algorithm, your decision tree evaluation techniques, your decision tree classification rules, and we're going to use these in a way to test how dependent our decision procedure is on the particular set of samples that you've been given. How we're going to do this is we're going to select 1/3 of the data that we're going to lay aside, and we're going to use as what we call a test set. So the test set we're just going to lay aside. We're going to take the remaining 2/3 of the data, which we'll call the training set, and we're going to train a decision tree or build a decision tree based on the 2/3 of the data set that you have. So use the training set, 2/3 of the data, to build a decision tree. From that decision tree, you can extract some decision rules, a set of nested if, then else statements. And then you'll use your decision rules to classify the testing set, the 1/3 of the data that you left out, that you didn't use when you built your decision tree. This will give us a feeling for how dependent our trees are on the data sets. Then you're going to repeat this. Oh, okay, so first, once you've constructed your tree, you've tested it. You've tested the tree on 1/3 of the data. You will then compute your statistics, accuracy, sensitivity, etc. Then you're going to repeat the process. You're going to take a different 1/3 of the data out, use the remaining 2/3 of the data, build a decision tree, classify the 1/3 of the data that you left out, the test set, compute your metrics, accuracy, etc. Then we're going to repeat it one more time. Take a different 1/3 of the data, lay it aside, train your decision tree, build a set of classification rules using 2/3 of the data. Again, compute the sensitivity, specificity, etc. Then across all three runs, all three iterations, all three folds of the cross-validation, you're going to compute averages. So what's the average accuracy across all three tests? What's the average sensitivity, specificity, and so on? And then you'll report the results that you got from each fold, as well as the averages across all three folds. I think that all of you are really well positioned to do this. You've built everything that you need. You just need to do a little bit of cross-validation now, and it'll be interesting to see what you come up with.